Pretty sure it's 4,096.
How do you put it in your calculator?
We'll talk about that in a minute. I'm going to go through the columns. Is everybody okay with the entire power column? You have them all correct. These three can be anywhere in there. And you're right. Is everyone okay with the power column? Is everyone okay with the base column? Is everyone okay with the exponent column? Is everyone okay with the repeated multiplication column? If there was going to be trouble, I would expect it there and there. That calculator no longer works. Oh, speaking of calculators, somebody, and I don't wish to actually accuse because I don't know which class it was, somebody has cunningly borrowed my very big expensive calculator but did not take the case that has my name on it. Yeah, that's one word for it. Or lying, thieving, conniving. There's many words else for it as well. That's the one I prefer to use because when, of course, you remove something from somewhere and it doesn't belong to you, that makes you a thief. So somebody has this calculator of mine. I would appreciate it back because they are expensive and I actually paid for this one. This one I didn't, but this one I did. So I would like it back. I would expect problems with one of those two. Were there any? And everyone is okay with the evaluations?
No.
Which one?
The second to last.
All right. So, without that negative out in front, if this negative was not there, then you have negative 4 repeated 6 times, yes?
Yeah.
1, 2, 3, 4, 5. Oh, I didn't write enough of them. So we got to have another negative 4 there. Right? Which would be negative times a negative, which would be a positive.
Then
Times a negative, which would be negative. Times a negative, which would be positive. Times a negative, which would be negative. Times a negative, which would be positive. So I would have positive 4,096. But the whole thing is negative. So this whole thing is negative. And negative, positive makes for a negative answer.
How would you punch that into your calculator?
To punch this into your calculator, if you have a forward calculator, which you do, you would punch in exactly what you see. Negative, bracket, negative 4, close brackets, the exponent button, which I think on yours is a little mountain. Oh, it's y to the x, so y to the x, 6 equals.
Okay. I did the long one and decided to just keep going and typing in 4 a lot. I don't know.
Which
And then what
you just stopped one too early. That's why you got 1,024, because that's 4 to the 5th. And then you didn't know about the negative.
Right.
Everyone is good with this page.
Yeah.
Yes?
Yeah.
All right. Now, I was informed by my other block that some of the classes in the 9th grade, they felt glossed over exponents a little bit. Meaning they did not delve as deeply into them as my students felt they should have. So some other students that have already had this lesson today said, no, we got all this. So for some of you, what I'm about to do is going to be a review. But that's okay, because the concepts in exponents are incredibly easy to understand. But to do an exponent question is incredibly complex. If you do not understand the difference between those two, allow me to put it into terms you may understand. All of you are aware of the building toy Lego, yes? How difficult is it to build something with Lego? No. Not at all. You pick up a block, you pick up another block, and click, you have the beginning of something. Yes? Easy. How many of you have seen the people who build, for example, the entire skyline of Manhattan out of Lego? Is that difficult? No, not at all. You are picking up a block, clicking it in with another block. Is it difficult to physically build? No. Is it complex? Yes, because you must apply a great many very simple concepts together to achieve a complicated whole. Yes? Same thing here. All of it is easy. Any single step is incredibly simple in exponents. Putting it all together, you can get a little lost. So you must pay very close attention, and you must be very attentive to detail. Because if you make one error, the entirety of the question is wrong. All right? All right. Let us move on then, cabbages. Everything on page 79 to do with numbers, you should already know from the 9th grade. Some of you will have used exponent laws with variables as well. Those are the people that are going to find this page a little bit dull. But that's okay, because again, you need to know how to do all of it. So I'm going to open by asking you for a number between 1 and 5. 3. Lovely. Now I'm going to ask for a second number between 1 and 5. Dan. 4. Excellent. Now, I'm going to ask for a third number between 1 and 5. 2. Lovely. Now, all of you should be able to identify in this expression right here the no. See, that's not what I want you to do. Don't guess. All of you should be able to tell me what the base is there. Excellent. What is the base there? 3. They are the exact same base, yes? Wonderful. Now, all of you should be able to tell me what is actually happening there. That is 3 times 3 times 3 times 3, correct? That is the yellow. Agreed? Excellent. What math is happening between the terms here? Multiply. Excellent. Times. Good. Now, what is happening here?
3 times.
Excellent. 3 times 3. Now, as you can plainly see, I have 3 times 3 times 3 times 3 times 3 times 3, which is a total of how many 3s? And now you all get to do what you wanted to do in the first place, which was tell me, you just add the exponents, you idiot.
Whoa, not the idiot.
No, that's what you were saying. It's like, Mr. Mars, why are you making this complicated? You just add the exponents.
I know what you're trying to do.
Which is, of course, all you are going to do with all of your grade 10 work. You are going to apply one of these 6 incredibly simple concepts. Unfortunately, you are going to possibly have to apply 7 of them to any single given problem. So you actually have to know what is going on. You cannot rely on the shortcut, which I'm about to give you right now, which is this. X to the a, any base to any exponent, multiplied by that same base to any exponent is simply that same base, and I add the exponents. All of you already know that. But I can write things that will mess you up. For example, is that correct?
Yes. No. Because you don't, well, yeah.
So far you have said yes and no twice each.
No, the bases are different, so you have to multiply them. You have to multiply the bases.
Okay, I didn't ask what to do. I'm asking you, is what I just wrote there correct? No, of course it is not. Why? They do not have the same base, so I can do nothing here except evaluate them. This, of course, is 9 times 16, which is 144, which is not 6 to the 6th. Okay? No, I don't want you to write that down. This is what you need to know. But as I was saying, it's very simple. And yet, I just wrote out a problem that half of you were like, yes, no, I don't know, maybe. It's the very first step. And already I have confused half of you. All right. Now, we are moving on to the second exponent law. Much like real life, can I forget the first law? Of course not, just like in real life. In Canada, I cannot walk up to Geo and hit him in the face with a crowbar. Sometimes I visit the United States. Am I allowed to walk up to somebody in the United States and hit them in the face with a crowbar? No, because I cannot forget that law. Clear? So in this one, we are going to continue with the same numbers. 3 to the fourth divided by 3 to the second. Now, in the third grade, you learned that symbol right there. And then you promptly never used it again. Right? Because you should have learned long division. And then, of course, you learned that we do not write that. What do we write instead? A slash or a fraction. This is, of course, 3 to the fourth over 3 squared. Now, what is that? Really? 3 times 3 times 3 times 3. Over. What is that? Really? 3 times 3. Boom. Boom. What is this? Really? Danish. Pardon? No. That's not what I asked. Again, you are all jumping to the end because you feel that because you know what the final answer, you know how to do this. That is not correct. Knowing the answer is not knowing how to do something. I will ask again. What is this? Just what I am. 3 divided by 3, which is what? 1. 1 times everything. Does that change its value? No, of course not. What is this? 1. 1 times everything after it. What is it?
3 times 3.
Continues to have the same value. Now, you all call this canceling. But do not call it canceling. Here is why. When I give you something like this, x plus 3 over 3, you all think you can do that. Well, you might not, Harsh, but most of your peers think you can do that.
You can't go backwards.
You cannot. So that is why I do not allow you to say you are canceling. What you are doing is dividing the same thing on the numerator by the same thing on the denominator, giving you a value of 1. What is left? 3 times 3, which is, of course, 3 squared. Now, tell me your shortcut. You subtract the exponents. X to the A over x to the B is x to the A minus B. Yes? Excellent. Now we are going to go to the third problem, and after that we are going to take a break, and you are going to think. I will not get to that. Raising an exponent to an exponent. 3 to the fourth squared. What is... What... Oh, you did it again, you sneaky son of a... What is that?
3 to the power 4.
3 times 3 times 3 times 3. What is that?
It's 2.
Which means, how many bases are there here?
2.
There are 2. Because that exponent means the base is happening twice.
Oh, that's great.
How do I write that properly? Yes, you do. What math is happening right there?
Multiplication.
Multiplication. So that is 3 times 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 3, which is 3 to the 8th. What is the shortcut? You multiply the exponents. X to the A to the B equals X to the A times B.
So we did there.
All right? All right. So now I want you to tell me, without writing it down, just use your brain, 3 squared times 3 to the 4th, all squared.
Without writing anything down?
Don't need to write it down. You tell me it's easy. I'm asking you to do 2 steps. Dan, 3 to the 12th. Why? So Dan did 4 times 2 over the bracket and got 3 to the 8th. Then he did 2 times 2 and got 3 to the 4th. And remembered that he was multiplying between 4 plus 8 is 12. Excellent. What is the other way he could have done it? He could have done
the exponents on the inside. And then
2, 3, 3. Oh, they're the same base. So I add 3 to the 6th squared.
Oh. And then 6.
3 to the 12th. Which way is correct?
The bottom one.
Both. Who decides?
You.
You do. Can I show you the way you have to do this?
No.
No. Because you need to make that decision. Yes? Excellent. Exponent of 0 has a bit of room because people have a lot of trouble with it. 3, because we're keeping with 3, to the 0 equals what? 1.
Why?
I was waiting for that. I'm actually glad people said 1, because the first answer in the other class was, of course, 0. Of course it is 1. Here is why. What is 3 cubed? What does that really mean? 3 times 3 times 3, and that is 27, yes? What is 3 squared? 3 times 3, which is, of course, 9. I have removed a multiplication here, which means here I have divided by 3, correct? Does everyone agree? Excellent. What is the next logical exponent here? 3 to the power of 1, which is? Which is 3. Divided by 3, correct? And finally, what is the next logical exponent? 0. So I divide by 3, and it is 1. Now, can I fill that part of the box in? Of course not. Why? Because 3 has not repeatedly multiplied, has it? Everybody understand? Some of you won't get that. That's cool. Fortunately, you have a very intelligent math teacher who's going to show you another way to prove it, so you remember how this works. That is this. 3 cubed over 3 cubed. What shortcut would you use there? Because all of you only care about shortcuts. 3 to the 3 minus 3, which is 3 to the 0, yes? But in actual math, of course, you know, this is really 3 times 3 times 3 over 3 times 3 times 3, which is, of course, 27 over 27, which is, of course, 1. If this equals this, which equals this, which equals this, and this equals this, which equals this, then what do you know about those two things? That they too must be equal.
So if we were asked the question, what's the base of 3 to the power of 0?
3.
You wouldn't write
3 is the base.
But you didn't
3 is the base.
write it?
It does, because there is no repeated multiplication. 3 is still the base. Right? All right. Now, next thing. Even though I reviewed this Thursday, a bunch of you are going to do this poorly. What is that?
-3 to have -1.
Negative 1. What is this? 1. What is -3? Oops. 3 to the 0.
-1.
Of course it is -1.
That's right.
Why?
Because you have the negative and a positive and a negative.
What's the base in yellow? No. 3. Every base to the 0 is what? 1. But this is saying negative, whatever that is. What is the base in blue? Every base to the 0 is what? 1. You just proved it. What is the base in the green? What is every single base to the 0? 1. What does that negative there mean? That whatever right after it comes up, it is negative. That is why that is -1. Do you understand? What is the notation in these 3 that tells you what to do with those negative signs? The brackets. Brackets exist in math to group things together. In the yellow one, there is no grouping. It is -3 to the 0. In the blue one, it is grouped. So it is not -3 to the 0. It is -3 to the 0. Yes? And in the green one, it is -3 to the 0. Now, can all of those intonations in my voice be expressed in writing? No, they cannot. Can they be expressed in your brain? Maybe, if you pay attention to what I say. Not a good track record on that. So you have to actually understand what the brackets are doing now. Yes? All right. After number 5, we are going to do some more of this stuff. Three squared times 2. No, sorry. 3 times 2 squared. What is the base here? 3 times 2. So what do I have? I have 3 times 2. How many times?
2.
Twice. So what is 3 times 2? 6. And 6, which is 36. Agreed? But please notice, what do I have there?
The same.
How many 3s, Dan?
2.
I have 3 squared. What do I have there? 2's squared. What is 3 squared? 9. What is 2 squared? 4. What is 9 times 4? 36. Is everybody with me? What did you notice about that 2? I should have done that a different color because I've already used blue and yellow. What did you notice about that 2 in that line?
Put them as the exponents.
It applied to everything inside the base.
Because they didn't have exponents.
So our rule is y to the a is x to the a, y to the a. It goes to both of them. Now I will ask you again, can I forget the previous 4 laws? Of course not. So let's do some application. Again, just with thinking. X, y cubed. No, I lie. Worst kind of liar. X, y cubed. Can I write that in any other way? I could write x times y. But that would be ugly, wouldn't it? And it would not appear as simple as this. And our goal in math is for everything to appear as simply as possible, yes? Okay. So what's the base here?
X.
No. Y.
Because a base always has an exponent. So
Everybody good? Okay. What's this?
x times y.
The base is xy. So how could I write that differently?
X to the power of 3.
x3, y3. Nicely done. X squared y.
X squared.
Oh, wait. Cubed.
X. Fantastic.
X to the 6th, y to the 3rd. Everybody still good? 2x squared.
2x squared. Power of 2. 2x2. Whatever it is.
2 squared x squared. 4x squared. Yes? 3x squared y cubed squared. Don't say it out loud. Think about this one. Just stop for a moment. Get your answer in your head. Just answer. Does everybody have an answer in their head?
Yes.
Okay. Who would like to volunteer their answer so you don't steamroller over everyone else? What is your answer?
3 to the power of 2, x to the power of 4, y to the power of 6.
Almost perfect. Because, of course, if we can evaluate, we would evaluate. So what should I write there instead of 3 squared? 9x to the 4th, y to the 6th. Because we know that 3 squared is 9. Because we know 3 squared is 3 times 3. We don't know what x is, so we can't give it a value.
Okay.
Is everybody good to there? Yes? Whoop. Turn the page over. Number 6. No, I lie. 8/4 squared. Now, does this look similar to this?
Yeah.
Is there a bunch of stuff going on as a base with an exponent? Is there a bunch of stuff going on with the base with an exponent? Excellent. What is that base? Do not tell me the value of that base. Tell me what the base is. 8 divided by 4. And how many of those bases are there? 2. 8/4. What would we write really instead of 8 times 8?
681.
There's 2 things I can write. I can write 64 or
8 times 2.
8 squared over 16 or 4 squared. Because, of course, just like I have mentioned many times, all the laws apply. When I had a bunch of stuff going on in a base, the exponent went to everything, yes? So the same thing happens here. That 2 ended up with the 8, and it ended up with the 4. Now, are these evaluatable? Yes. It is 64 over 16, which is 4. Correct? Now, is there another way to get the 4 from here? 8 divided by 4 is 2, and 2 squared is 4. Is everybody good with numbers? Great. So the shortcut, of course, is x over y to the a is x to the a over y to the a. Yes? So now we are at the point where all of you should have been by the end of the 9th grade. Which means every single one of you with this refresher should be able to solve what I am about to write here. Okay? There are a lot of ways to do this. You need to decide on the way you would do this. And again, I do not even care if you don't write it down. I want you thinking about what you would do. There are a bunch of ways you could do this. Does everybody have an idea? I am not asking you if you think you are right. I'm not asking you for you to tell me if you are right. I'm just asking if you have an idea of how you would approach this. Would anybody like to say what they would do first? Dan.
So for the top, I did 9, x4, and y2.
Okay, so Dan took that law, which is law 3, and applied the exponent to everything. To get 3 squared, x 2 times 2, and y to the 2. To get a total of 9x to the 4th y squared. Yes? Excellent. And then you did the same thing on the bottom. So you got 2 to the 2 and x to the 2 to get 4x squared. Excellent. Zach, did you do something differently? Oh, so you agreed with Dan in his first step, and then you looked at that and said, that does not look right to me because I have far too many x's. And of course, then I remembered law 2, which says this is x, 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 x over x, x. 1, 1, leaving me with x squared. So, of course, you changed your final answer to 9x squared y squared over 4. Because 4 x's up top and 2 x's on the bottom cancel out. There were 4 in the numerator, 2 in the denominator. 2 of them cancel out, leaving me with x and x squared. Or you remember the law, 4 minus 2. Is everybody good? Okay. Now we get, as you can see, you have a whole page here. Why? Because this is crazy. Some of you will have seen it. That's okay. A great many of you will have not. I am going to show you why, because of course, if you know why something works, you know how to do something. So, remember this chart. 3 cubed, 3 times 3 times 3, 27. 3 squared. 3 times 3, 9. 3 to the 1, 3. 3. 3 to the 0. Can't write anything there. 1. Yes? Excellent. What did I do every step of the ladder? I divided by 3. Yes? So, what then is this box going to be? What? Why would it be negative? 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. So what must this be? 1. No, don't give me a decimal. Stop decimals. 1 divided by 3. What is the next logical one? Use your brains, people. 1, 3, 9. 1 over 9. What's the next one? 1 over 27. What is the next logical base and exponent here? What is the next logical power? 3 to the negative 1. 3, 2, 1, 0. Negative 1. What is the next logical power here?
Negative 2.
What is the next logical power here? Why can we not fill any of this in?
Because there's not.
Because I can't multiply 3 by itself negatively times, can I?
Yeah, you can't.
But I do know that 3 to the negative 1 is 1/3, yes? Which means 3 to the negative 2 must be 1/3 times 1/3, 1/9. 3 to the negative 3 must be 1/3, 1/3, 1/3, 1/27. Yes? Please notice that these negative exponents have never given me a negative value, have they? Will they? No, because I can always divide by 3. Will I ever get to 0? No. Will I get very, very close to 0? But I will never get to 0. And if I never get to 0, can I ever get to negatives? No. Does everyone understand? All right. What then, knowing what you know, is this answer? This is law 2.
So we do 3 minus 5. And
3 to the 3 minus 5, which is 3 to the negative 2, which is 1 over 3 to the positive 2, which is 1 over 9. From right here.
3 to the positive 2. Where would you get that?
From right here.
Negative
Ariana, what's on the bottom here?
3.
And another 3. What is 3 times 3? Now, Ariana accidentally has led us to our next piece of knowledge. What do you notice about 27? There is a significant digit that has not been written there because math people are lazy and do not write it, even though it is supposed to be there. What should that be written as? 27, not to the power of 1. 27 over 1. Because every number is a rational number. It is always divided by something. We don't write this, or it would be a pain.
So then the next one would be 9 over 1?
Yes. And what would this one be?
3 over 1?
3 over 1. Now, what do you notice about that and that?
Oh, they're just flipped.
You say that like with that tone of voice, but that's actually a very significant piece of knowledge. Sarah, they are reciprocated, which is what I was going to ask next, if anybody could remember that proper word. They are reciprocated,
1 over 1.
which automatically means, well, 1 over 1 reciprocated. 1 over 1 is still 1 over 1. Now,
So what would it
that should automatically give you all of these numbers. What is 2 squared?
4?
4. 4 over 1. What is 2 to the negative 2? 1 over 4. What is 4 squared?
4 over
16. What is 4 to the negative 2? 1 over 16. Is everybody good? Stop. You're still not ready. I would not have moved yet, Gio.
Wait. What would you do with the 1 then?
Which one?
If it's going to be this, like the same thing, 1 over 1, 1 over 1. On that
What is 1 squared?
2. 1 over 1.
Is 1 over 1.
Yeah. And then 1.
What is 1 to the negative 2? Flip it. Okay. Is everybody good? Now, why does this have to happen? We cannot fill in these blocks, can we? Because they make no sense. How can I have something multiplied by itself negatively? It doesn't exist, does it? So that should give you a warning. Am I allowed ever to have that in a final answer? Of course not. Why? Because x cannot multiply by itself negative times. What is this answer? 1 over x squared. We reciprocate and the exponent becomes positive due to what we just proved. Yes? Excellent. So you now all agree that a negative exponent makes no sense. And if I have a negative exponent, I must have to reciprocate the base.
And the answer is always going to be a fraction.
Is everybody good with that? Yes, go to the bathroom. No, the same person who asked every single class to go to the bathroom.
So the answer to a negative exponent
Right in the most
always
important
be a
part, too.
fraction.
That's okay.
What?
Not you. I'm not talking to you. Amazing. There's somebody to talk to in the hallway? I think Grovier's smarter than me.
So it's always going to be a fraction.
No.
A negative exponent.
No.
Okay.
Eh? What then, using your brain, is that?
Because what?
It has to reciprocate.
So you just put the 1 on the bottom
Yeah.
on the answer.
Now, wait. Remember, you can't forget any of the other laws.
So that would be x over y 2 times.
Y squared over x squared.
Because you just flip it and then you turn it into
Negative exponent flips the base and becomes positive. So this becomes y over x to the positive 2, which becomes y squared, x squared. Yes?
Oh. Man.
Remember how I warned you? All the steps are easy, but it gets complicated. Wait. 3x squared y to the negative 2. You already know.
Oh, it's just over under
When you add
What is every single base? Over 1. What does a negative exponent do to its base?
make a negative.
No.
Flip it.
Flips it. What does that do to the exponent?
Make it positive.
Where does that exponent go?
Onto every.
Everywhere. 1 squared over 3 squared x2 times 2 y squared. 1 over 9x to the 4th y squared. Is everybody good?
What is 1 squared? So you just took. Okay.
Is everybody good? All right. 1 over 2x squared y to the negative 2.
2x squared y over 1.
2x squared y over 1. Do we ever write over 1?
Yeah.
No need. Not.
So now that
And all of that is to what power?
the positive 2.
Positive 2, which is
2 squared.
2 squared x 2 times 2 y squared. 4x 4th y squared. Huh? Everybody still okay?
Yes. Okay. 1. 1. 1.
Sorry.
What? Now we're doing something without a 1. Cancel the x's and the y's. Not cancel.
All of a sudden now, we have 4 or 5 exponent laws here. Can I apply what I just did over here to here? Sure I can. What did the negative exponent do to every base?
Flip it. So
Flipped it. So what will happen?
2xy over 3x squared y.
To what power?
Positive
2. Now what?
2 squared x squared
4x squared y squared over
9x
9x
2 times 2 y squared.
4
Okay.
y squared. Now what?
Have negative 9.
Woo!
2 and 2. Same thing on top and bottom. What happens?
You take them away.
Gone. 2 and 4.
You subtract.
Has like 2 minus 4, so that's negative 2, so you have to reciprocate again.
4 over 9, because I can't do anything with that, right? And this becomes x to the negative 2. Over what?
Nothing.
What's the base? 1. But it's a negative, so what happens?
1 over x squared.
4 over 9. Where does that x squared go?
Positive to the 9 and the x.
And the exponent?
Positive 2.
Positive 2. And now we're done. Now I ask you, were any of the steps new?
No.
No. Does it start to get complicated?
No. Well, yeah, but. Oh my god. What the heck? What the heck? Oh, Kittimer. Bring it. Let's go. What you got? Oh, that's great. That's amazing. Okay, so that's 4.
All of a sudden, does the road ahead present itself as clearly here as it did here? No. Are there many paths you could take here? Give me any of the 7 laws that I could apply right now. Just give me one that I could apply right here. Joseph says I could flip the whole base because there's a negative exponent, yes? That is a perfectly acceptable law. Gervier, is there another law I could apply here? Pardon me? Law 2, which is the division and subtraction, yes? Could I do law 2 here and here?
Yes.
I could. Is there anything else I could apply right now? Law 3, which is an exponent over brackets, does what? Goes to everything and multiplies. 3 different choices for the beginning of this question. Is one any more or less correct than the other? No. So here's what we're going to do. You're not going to write it down because it's getting recorded. We're going to do all 3. Who was first? Joseph said he's going to flip this, yes? So we've got Joseph going here. Flip it. 4x cubed y. What exponent? Still negative 2. Because flipping it only affects which of these 5 exponents? Just that one. That's Joseph's first step, yes? In blue, we'll do Gervier's first step, which was apply law 2, yes? 3 and 4, we can't apply anything to there, because 3 doesn't divide by 4 at different bases, yeah? 3 minus 4. What is 3 minus 4? 7. Positive 7. Negative 2 minus 3. Negative 5. Now, I could put it here Or I could put it here with the positive.
And it would make sense to put it
And all of that,
the bottom.
in Gervier's first step, what is the exponent out here now?
2. Positive
No.
0.
Still negative 2. We haven't flipped anything. In Gervier's steps, yes? No. 3 is still in the numerator.
Oh, he did.
And the third option was Ariana, I think, who wanted to apply law 3, yes? Which applied to everything. So she had 3 to the negative 2. X, what's negative 2 times negative 4?
Negative.
No, positive 8. What is negative 2 times 3? Negative 6. Over 4 to the negative 2. X to the negative 6. And Y to the positive 4. Does everybody understand the first step for each person?
Are you reading from the...
Is everybody cool? All right, now, Joseph, you liked your first step. What law would you apply now? You would do Gervier's step. You would start canceling in here. So Joseph's next move would be 4. 3 minus 4 is what?
7.
X7. 2 minus, negative 2 minus 3.
5.
Negative 5. Yes? And what is Joseph's outside exponent? 2. Still, no, he flipped, so he gets a positive there. Now let's go to Gervier. Gervier, what would your next step be if this was your first step? Pardon? You would do Joseph's step here. But you want to make this positive, so you'd flip. 4y fifth over 3x7 to the positive 2, yes? Okay. And Ariana, what would your next step be? Where does 3 to the negative 2 have to go? It's got to reciprocate, yes? So it's going to come down here, 3 squared, and be positive. Where does this negative guy go?
To the top.
Reciprocates up here and becomes positive, yes? 8 minus 6.
8 minus
14.
yeah.
Negative 6 minus 4. Y to the 10th, yes? Everybody good? Back over to, oh shoot, this is supposed to be blue. Damn it, it didn't change. Oh well. Joseph, what's your next move? You're going to square everything. So you're going to get 4 squared, x to the 14 over 3 squared, y to the 10th. Gervier, what are you going to do? You're going to bring the 2 in. 4 squared, y to the 10 over 3 squared, y to the 14. Yeah? Sorry, dummy head. Ariana, what's your move?
Subtract the exponents.
No, you're done. What's 4 squared? 16. X to the 14th, 9, y to the 10th. Yes? Same base? No, so she's done. Joseph. Same thing. 16x to the 14th, 9y to the 10th. Now, what went wrong here?
What?
Where did we go wrong? Because here, we've got 16, right? 9, right? Same. But our x's are reversed. So let's see what happened. Gervier's first move was to bring everything in, right? Or no, his first move was to simplify. Negative 4 minus 3 is what? Negative 7. So where should that have been?
So you're supposed to, you have to like
So this
do the exponent on the
should have
outside.
been 7 down here, yeah? And 3 minus 2? No.
Positive
Plus
5
5.
and on top.
So now we would have been okay, yes?
So are you showing us that there's many ways you could do it?
Yes.
It
It doesn't
doesn't matter?
matter.
But to make it easier, you would have done like Joe's.
No. There's no way to say which is the way to do it. Because kid X might not see one of these steps as being easier. What happened at the end? No matter what path we took, we got the same answer. Does everyone understand?
Would it be easier to flip it first and then...
Ariana.
Okay.
I don't know what that
This
is.
is an emergency announcement. A school-wide lockdown is being implemented. All students
Over there.
are immediately back to their classrooms. Teachers lock their classroom doors. No one is to leave the classroom until an all clear is given. This is an emergency announcement. A school-wide lockdown is being implemented. All students report immediately back to your classrooms. Teachers lock your classroom doors. No one is to leave the classroom until an all clear is given. This is an emergency announcement. A school-wide lockdown is being implemented. All students report immediately back to your classrooms. Teachers lock your classroom doors. No one is to leave the classroom until an all clear is given.
Stay off your phones. Cannot stress this enough. Last time this happened.
This is an emergency announcement. A school-wide lockdown is being implemented. All students report immediately back to their classrooms. Teachers lock your classroom doors. No one is to leave the classroom until an all clear is given.
The last time this happened, networks crashed. Keep off your phones. There's nothing to worry about.
This is an emergency announcement. A school-wide lockdown is being implemented. All students report immediately back to your classrooms. Teachers lock your classroom doors. No one is to leave the classroom until an all clear is given.